Hello, in this video, we're going to look at lesson 5.7 on the Pythagorean Theorem. The essential question for this lesson is how do you use the Pythagorean Theorem and its converse to solve problems and classify triangles? The Pythagorean Theorem is one of the most well-known theorems in all of mathematics. You've probably heard of it before in your previous algebra courses. The Pythagorean Theorem is a squared plus b squared equals c squared, where the legs are the a and the b, and the legs are the two sides that form the 90-degree angle. It doesn't matter which leg is a and which leg is b, you can pick. The one that you need to make sure that you get in the right spot is the hypotenuse. And the hypotenuse is the c in the formula, and that's always going to be directly opposite the 90-degree angle, or across from the 90-degree angle. So when we set up our problems, I'm always going to label the C first. That's the one that we need to make sure we get in the right place. And then for the remaining two sides, we can pick one to be A and one to be B. As we're working with the Pythagorean Theorem, there's going to be two buttons that you'll need on your calculator. Notice that it has squared symbols. So to get a squared, you're going to use the x squared button on your calculator. That gives you the exponent of 2. So, for example, if you want to figure out what 13 squared is, you would type 13 and then click that x squared button, and your calculator will then show 13 with an exponent of 2. Once you hit enter, or the equal button, you will then see 169. The other thing we're going to need to do with our calculator is calculate some square roots. To get a square root, you're going to first click the second button on the calculator. It's usually a different color from the other buttons. Second, followed by the x squared key. And you'll notice above the x squared key, there's a little square root symbol. And by clicking the second button, that gets you to the square root button. Squared and square roots are inverses. So for example, if you want to calculate the square root of 100, you're going to click second x squared, and then you're going to see this on your calculator. Now you just type 100, you close your parenthesis, you click the enter or equal button, and it'll give you 10. So square roots, we do second x squared, and squared, we just use the x squared key. Now let's try a couple examples. We're going to use the Pythagorean Theorem to find the missing side in the right triangle, and we'll round to the nearest hundredth. The hundredth place is 2 decimal positions. All right, so the first thing we want to do is label A, B, and C. I always start with C. Remember, C is the hypotenuse. C is the one that's directly across from the 90. So in this triangle, the C is the X. A and B are the other two sides. So we can now just take those values and substitute them into the Pythagorean Theorem, A squared plus B squared equals C squared. So A squared is going to be 7 squared plus B squared, which is 4 squared, equals C squared, which is the X squared. And now you can square those using the squared button on your calculator, or just 7 squared is 7 times 7, so 49. 4 squared is 16. And then if we add the 49 and the 16 together for like terms, that makes 65. 65 is equal to x squared. We need x. So to undo the squared, we just take a square root of each side. The square root cancels out the squared. So now I'm going to use the second x squared button on my calculator and then type 65, hit enter, and the calculator gives us 8.0622. We want to round that to 2 decimal positions. So I like to draw a line right here and look at what's in the third spot. Well, it's a 2, and 2 rounds down. So our final answer is just going to stay as 8.06. Let's put the unit back in, 8.06 kilometers. Here's another triangle. This one, you'll notice that we have the C side. It is 16, and then A and B are the other sides. So if you want to just go straight to putting them in the formula, I already have the formula written like right over here. So we can just look at that and say, okay, I need x squared, because a squared plus b squared, 11 squared, equals c squared, so 16 squared. And then once again, you're going to get your calculator to help you with the squaring. 11 squared is 121, and 16 squared is 256. Before we take a square root, we need to get the x squared by itself. You want it to be alone before you square root each side. So I'm going to clear that plus 121 by subtracting 121 on each side to give us x squared equals 135. Now we can go ahead and take the square root of 135. And when we do that, the calculator gives us 11.6189. We'll round again to the nearest hundredth, which is 2 decimal positions. So I'm going to look right here, and the 8 in the third place tells us we round up. If it's 5 or more, you round up. So the 11.61 is going to move up to 11.62. So that will be our final answer for the missing side. Here's a try now problem. If you'd like, you can try this problem on your own. You can pause the video now, and then when you hit play again, I will have the solution posted. Please pause your video. Okay, here is your solution. The missing side there is the hypotenuse, the C, and when you do the calculations, you'll end up with 11.18 centimeters. In this next example, we're going to look for a Pythagorean triple. And a Pythagorean triple is going to be a set of non-zero whole numbers. Whole numbers mean no decimals, no fractions. So just a nice whole number, A, B, and C, that satisfy the equation a squared plus b squared equals c squared. So far, the examples that we've looked at have all had one side that we had to round, where it wasn't a whole number. If you do a right triangle and all 3 sides are exact whole numbers, we say that the sides form a Pythagorean triple. Some common examples of Pythagorean triples are 3, 4, 5, and 5, 12, 13. So we'd have 3 squared plus 4 squared equals 5 squared. So that's why it's a Pythagorean triple. And 5 squared plus 12 squared is exactly equal to 13 squared. So when we find the missing sides in these triangles here below, we'll proceed as normal, but then at the end, I'm going to say if it's a triple or not and check for are all the sides whole numbers. So beginning with this first triangle in example 2, notice that the C is across from the 90, which is 12, and then our missing sides are either A or B. I let A be the missing side, B is 4, and C is 12. So we're going to go A squared plus 4 squared equals 12 squared. And then we can use our calculator to help us with the calculations here. Before you take a square root, you need to get the A squared alone. So we'll have to subtract 16 on both sides to give us A squared equals 128. Now to get our missing side, we just need to grab a calculator and take the square root of 128. And when we do that, the square root of 128 is 11.31. So that's our missing side, 11.31. And that's not a whole number. We had to round. So this is not a Pythagorean triple. If it was exactly 11, we'd have a Pythagorean triple. But since we have a decimal position, it's not a whole number, it's not a Pythagorean triple. Go ahead and try the try now on your own. Please pause the video. When you hit play, I'll have the answer posted. Here is your solution. The missing side is C, and when you do the calculations, it ends up equaling exactly 50. So all three sides are whole numbers, 14, 48, and 50, which means that the sides form a Pythagorean triple. The Pythagorean theorem can also be used in reverse to help classify a triangle. A squared plus B squared equals C squared only works for right triangles. But if we let C be the longest side in the triangle and we test out the relationship between C squared and A squared plus B squared, that value of how they compare is going to determine if we have an acute, right, or obtuse triangle. So if the C squared value is larger than the A squared plus B squared value, that will always be an obtuse triangle. If the C squared is less than the A squared plus B squared, then it will be an acute triangle. And if C squared is exactly equal to A squared plus B squared, then it's a right triangle. So we can use the Pythagorean theorem in reverse to decide what type of triangle we have. So let's look at problem A. The first thing I need to do is make sure that I pick C as the longest side. I like to just order the sides in order from smallest to largest. So I have 16, 48, and 50. So that's A, B, and C. We want to compare C squared with A squared plus B squared. So I'm going to actually put C squared on the left and then A squared plus B squared on the right so that it looks just like the Pythagorean inequalities theorem up above. So C squared is 50 squared, A squared is 16 squared, and B squared is 48 squared. Now you can just grab a calculator, and 50 squared is 2,500. And then you can type this all in one in your calculator. So do 16, the squared button, and then plus 48 and hit the squared button again, and all in one step we can get 2,560. So those are not equal. Let's put the inequality symbol. The inequality has to be opening toward the larger number. 2,560 is bigger than 2,500. So we need the less than symbol here. And you can see that if we have a less than symbol, this must be an acute triangle. Let's try another one. So this one here, my three sides are 3.6, 7.7, and 8.5. So A, B, C. We'll compare C squared and A squared plus B squared. And we can do most of this in our calculators. So I need 8.5 squared and then 3.6 squared plus 7.7 squared. 8.5 squared is 72.25. And then if we do 3.6 squared plus 7.7 squared, we can type that all in one in our calculator. And that is also 72.25. So this time, C squared is exactly equal to the A squared plus B squared, which makes this a right triangle. Go ahead and try problem C on your own. Pause the video now, and when you hit play, I'll have the answer up. Okay, here is your solution to problem C. C squared is 121, and the A squared plus B squared is 117.13. So this time, 121 is greater than 117.13, and if C squared is greater than A squared plus B squared, that means the triangle is obtuse. The last topic of this lesson is using the Pythagorean theorem to solve some real-world problems. We're going to start by drawing a picture. If you can visualize the situation, once you get the triangle set up, it'll be exactly like all of the other problems. The hardest part is just visualizing the situation. So we have a platform that is 2 feet high, and an accessible ramp must be 25 feet long. Find the horizontal distance from the base of the platform to the end of the ramp. Okay, so we have a 2-foot platform, so we need to get up 2 feet, maybe to get in a door or something. And then we have the ground, and the ramp is going to be this like slanted surface here. So this is my ramp, and the ramp has to be 25 feet long. So the ramp itself is the slanted side, the side that you would walk up to get to the top of that 2-foot platform. That's going to be a 90-degree angle right here because the platform has to be perpendicular with the ground. So here, the 90 is in the left corner, and then my ramp is C, and the other sides are A and B. So for the horizontal distance, that's just going to be the B. So now we can actually just set up a Pythagorean Theorem question. A squared, so 2 squared, plus B squared equals 25 squared. And we do the same thing we did on all the other questions. Do the squaring on your calculator. Get B squared alone now by subtracting 4 on each side. And then we'll go ahead and take a square root of that. And when we type the square root of 621 into our calculator, it ends up being 24.92. We're going to round this time to the nearest tenth of a foot, which is 1 decimal position. So if I look at what's in the second decimal position, it's a 2. 2 rounds down, so I'm going to keep it at 24.9. So the horizontal distance from the end of the ramp to the base of the platform is 24.9 feet. Here's another example. How far from the base of a house should you place a 14-foot ladder so that it reaches the gutter 12 feet above the ground? I'm going to start with a picture here. So this is like the side of my house, and we have a ladder leaning against the house. So the ladder is going to be something like that. There we go. And we're told that the ladder is 14 feet. And it has to reach a gutter, which is 12 feet above the ground. So this is going to be 12 feet. We'll assume that the ground and the house are perpendicular, so the 90-degree angle would be right here. And the ladder there is the slanted side there, that's the C. The other sides are the A and the B. So we can set up a problem here of A squared plus 12 squared equals 14 squared, and then proceed to solve it as we did the other questions. I'm going to subtract 144 on each side to get A squared is equal to 52. And then we'll grab a calculator and take the square root of 52, which is 7.211. Again, we'll round to the tenths place. So if I look at the second decimal position, it's a 1. 1 rounds down. So it needs to be 7.2 feet from the base of the house. So this distance right here from the house, 7.2 feet. Here's one more example, and this time we have Jessica leaves her school and rides her bike 3 miles south and then turns and rides another 5 miles east. So south is this way. So we went 3 miles south. And then east is this direction, 5 miles. So I'm just using like the standard directions here, north, south, west, east. And we want to know how far away is Jessica from the school. So the school is where she started, and she's going to end right here. How far away is she? Well, we need this side here, and south and east are 90 degrees from each other. You can see all of the corners in a compass are 90 degrees. So the distance that Jessica traveled is going to be the C. the distance that she is away from her school. And now you can set up and solve the problem. So here's your solution. It ends up being 5.8 miles. And that's it for this video. Thanks for watching. Bye.